Alright, here we're going to start looking at examples of the chain rule. And what the chain rule says is that if you've got a function of a function, like what it's saying here, so y equals f of g of x, to take derivative of that is you take derivative of the outside part and leave the inside part as it is, and then the chain rule comes along, is you times that with the derivative of the inside part. So that was it. That's the chain rule, and I would say it's one of the most, it's actually the most used rule, differentiation rule. So yeah, it's widely used. Let's look at this example. Let me just zoom in the camera. So let's say if we got f of x, the function of x, f of x equals 3 times x to the power 4 plus 3x to the power 9. This is 9, by the way. Might look small. But anyway, what we do here is, obviously we separate 3 outside, and then we put it back later after we do the derivative. So derivative of fx equals to 3. And then what we do here is, let's pretend that this bit, we look at the most outside part, which is 9 in this case, and we pretend that the inside part is just x. So what we do is we times the coefficient of the outside part times x, right? And then take 1 from the power, which is going to be to the power 8. Sorry about that. But we're here, we don't actually have x. We've got x to the power 4 plus 3x. Leave it as it is. Now the chain part, as I said, chain part comes along. So we take the derivative of the inside part. Do you remember here? So yeah, now we take the derivative of the inside part, which is this part. So we times it with derivative of that would be x to the power 4 is going to be 4x to the power 3 plus 3. So that's basically the chain rule derivative. Now we're just going to clean this up a little bit. Let me just zoom out. So what we do here is we distribute the 3 inside the bracket, so that's going to be 3 times 9 is 27. And then leave that as it is, x to the power 4 plus 3x to the power 8, and then times 4x to the power 3 plus 3. Alright, let's do another example just to make sure that we got the chain rule right. So in this example, we got two expressions, and there's subtracting between them. So what we do is take each piece and take the derivative of it on its own. Again, here we got a fraction, but that's fine because we can take 1/3 outside the derivative and then derive the numerator on its own. So derivative of that, g prime x equals to 1/3. We take 1/3 out, as I said. And then now, again, like we used the last time, we take the power 1 from the power, and we multiply the power. So it's going to be 3, and we leave what's inside the bracket as it is, minus 2. Sorry, it's just a little bit small because I'm running out of space, but I think it's clear what we've done here. And then what we do is we use the chain part now, which is the derivative of the inside the parentheses. So x cubed minus 2, the derivative of that would be 3x squared, and the derivative of 2 is just 0. So that's the derivative of the first part, chain rule, the first part, minus. Now we got this part, 5 times x plus 2 cubed, all cubed. So what we do is, again, take the 5 out, number out. Sorry, the 5 looks a little bit funny. So what we do is take the power, times it with inside x plus 2, so subtract 1 from the power, so that's going to be squared, and then we take times the derivative of the inside part. The inside part is x plus 2. Derivative of x is just 1 and 2 is 0, so times 1. So we don't have to write times 1, just leave it as it is. So now let's just clean this a little bit. So in this part, notice that we've got a third here times 3, so 3 would cancel each other out with a third. So we're left out with 4x squared times this. Let's just put x squared up front first, and then times the what's inside the bracket, minus 2 all cubed minus. And this part, 5 times 3 is 15, and then the bracket comes along. So that's actually our derivative. 4x squared times x3 minus 2 all cubed minus 15x plus 2 all squared. So yeah, that's all about the chain rule. So that's the derivative of our example.